In part 2 of the video for linear functions, I want to spend some time graphing some linear functions, get some good practice in there. So when I look at this, what I'm doing is I'm thinking about g of x equals negative 3x plus 4. That's essentially y is equal to mx plus b. It's already given to us in the format that we need, which means b is the y value of the y-intercept. So we could plot that point 4, okay, and then m, remember, is your slope, and that's negative 3. Now, we could put that in fraction form, and remember that is rise over run. So from our point 4, we're going to rise negative 3, which essentially means we go down 3. 1, 2, 3, don't make a mark there. You still must run 1, and since it's a positive 1, you go to the right. You could do it again. From there, you go down 1, 2, 3, and go to the right 1. You could continue that 1, 2, 3, right 1. You could also go the opposite. You could also say this is 3 over negative 1, which means up 3 and left 1. Up 3, left 1. You connect these dots. You certainly don't need that many. And then there is the graph of your function, g of x equals negative 3x plus 4. Notice our next problem once again is in the form y equals mx plus b. Notice our b this time is negative 1, so that's our y-intercept. We plug down here at negative 1, and our slope is 5/3. That's our rise over our run. So from negative 1, I can count up 5 and right 3. So I count 1, don't count where you start, that's 0. 1, 2, 3, 4, 5, and then right 1, 2, 3. You could do it again. Up 1, 2, 3, 4, 5, and then right 1, 2, 3. You also have the option of doing negative 5 over negative 3. Notice that would simplify back to positive 5/3, which means go down 5, left 3. So if I go from here, I can count 1, 2, 3, 4, 5, and left 1, 2, 3. And I notice that all lines up to give us our straight line function of f of x equals 5/3 x minus 1. Alright, negative 5x plus 3y equals 15. Now notice the difference. If I flip back to the previous problem, that said f of x equals. This does not. As a matter of fact, your y is mixed up into the rest of your equation. So this is not y equals mx plus b. You cannot read the slope directly from this equation. You must solve it for y first. That's not a problem, right? We can just simply add 5x to both sides of the equation, okay? Or just think, hey, I need to move this guy over here. If you do, that changes the sign. So it gives you 3y equals, instead of moving it to the back of the 15, I'm going to put it in front. So positive 5x, and the 15 is positive, so I put plus 15. Now the next step is you have to remove the 3. Since 3 is being multiplied by y, I'm going to undo that multiplication and divide by 3. So I have y equals 5/3 x plus 5. Now we are in the form of y equals mx plus b. So our b is 5, and our m is 5/3. So remember b, that's the y value of the y-intercept. So I'm going to go up to 5 and make my first point. You always use the y-intercept first. And then my rise over run, so our rise 5 and our run 3. So from 5, I count, don't start counting where you are, okay? You count the next one, that's 1, 2, 3, 4, 5. Don't make a mark there, you still have to run 3, 1, 2, 3. Now notice that's about to go off my graph, so maybe I should go the other way. Well, positive 5 over positive 3 is equivalent to negative 5 over negative 3. So I'm allowed to count down 1, 2, 3, 4, 5 and count left 1, 2, 3. And that's definitely enough to graph our straight line. So the point of this problem is to show you that if your problem is not in slope-intercept form, which is what y equals mx plus b is called, then you need to isolate the y by solving for y, and then you can determine your y-intercept and your slope from your equation. Now this guy looks completely different, right? Y equals -2. Now if I think about that in terms of y equals mx plus b, notice the mx is completely missing. So we really have y equals 0x plus b. So that's y equals 0x minus 2. Okay, again because there's no mx there. So our y-intercept is -2 and our slope is 0. So if you think about 0 is rise over run, you don't rise at all and you run however much you want. Now, if you want to go through that much trouble every time when you have one of these, you certainly can. I don't advise it. What I advise is what we talked about in the last video, is the fact that if you have y equals a number, that is always a horizontal line at that value. So I think that is well worth memorizing. Remember, horizontal lines have 0 slope. There's no incline at all. And I think that's much easier to memorize than trying to change this into y equals mx plus b. Okay, our next problem, x equals 4. Again, notice this doesn't have a y. It's very similar to our last problem with the horizontal line. And there's no change in this to y equals mx plus b. It's just not in the format because there's no y at all. We can't put this in slope-intercept form. So this one you must have memorized, or you can think about it in terms of a t-table. In the last problem we could have done this as well. Now normally we pick values to go in for our x or our independent variable, but it says x is 4. So no matter what, x is 4. We can't pick anything else. And y can be anything you want, like 0, 1, 2. So you have 4, 0, 4, 1, 4, 2. You see that gives us a vertical line. Now, do you want to go through that much trouble every time? I don't. I think it's easier to memorize x equals a number. 100% of the time is a vertical line. Okay, so again, y equals just a number is a horizontal line. X equals just a number defines a vertical line. The next problem we need to graph. Now notice this does have an x and a y in it, so this is not one of those simple vertical line, horizontal line situations. This can be written in terms of y equals mx plus b. It's not right now. So what I need to do is I need to isolate the y, right? I need to get the y by itself. So I'm going to move this x to the other side. If you remember the trick to move a term to the other side, you simply change it. Now that came from really subtracting x from both sides. Notice how I put the x term in front of the constant term. So that's in that classic y equals mx plus b format. We're not yet there yet though, because we have to get rid of the -4. So I'm going to divide each one of these terms by -4. Okay, now the reasoning for that is whatever you do to the left, you have to do the right. It's called a property of equality. And the reason we're dividing is because the -4 is being multiplied by the y, and we've got to undo that process. So the -4's cancel here. I'm now left with y, just like what I want. -1 divided by -4. The two negatives cancel. And if you like, you can put a 1 in front of that x. And there you go. And then -8 divided by -4 gives me a +2. So you see your y-intercept, or your b value, is 2. Okay. And then your slope, m, is 1/4. So first I plot my point 2. And then my slope of 1/4 means I go up 1 and right 4. Remember, the top number is always up and down. Bottom number is always left and right. I do that from my y-intercept. So I count up 1 and right 1, 2, 3, 4. I can do it again. Count up 1 and right 1, 2, 3, 4. I connect the dots. And there's my line. Now to remind you, notice this is an increasing line. It's rising from left to right because we have a positive slope. If I go back a few problems, Notice this guy is falling from left to right or decreasing because I have a negative slope. -3 was my slope. So we have another linear equation to graph. Now notice this one, it's not y equals mx plus b, it's f of x equals mx plus b. Well, that's perfectly okay. We can handle that. That's no different than saying this. So my y-intercept, or my b value, is -4, and my slope, or my m value, is 2/5. So from this is positive. We know our graph's going to be going up from left to right. It's going to be increasing. But first I plot my y-intercept, and then remember I count up to right 5. 1, 2, 3, 4, 5. That takes me here. I do it again, up to right 5. 1, 2, 3, 4, 5. There's nothing wrong with going down 2 and left 5. That comes from thinking about this in terms of -2 over -5. And that gives me this point. Notice they all line up nicely in a straight line, and that is my increasing function because I had a positive slope. All right, next I want to begin talking about parallel and perpendicular lines. You need a definition for parallel lines, and you need to know what perpendicular lines mean as well, and I will get to that in just a second. But I have a problem for you to get this thought started in your mind. Graph the equations on the same axis to determine how the graphs are related. Okay, so I've got two different equations here. I want to take a look at first at x minus 3y equals -9. Now this is not in y equals mx plus b form, right? So that would help a lot. So I'm going to move the x over, which means I'm going to change the sign. It gives me -3y equals -x minus 9. My next step is to divide each one of these by -3. To remove the -3 that's being multiplied by the y. So that gives me the final result of y equals, the -1 and the -3 cancel. So you can think about that as 1/3 x, and the -9 and the -3 cancel to give me +3. So my b value, or my y-intercept, is 3, and my m value, or my slope, is 1/3. So I'm going to plot that first. So I go up to 3 for my y-intercept, and I go up 1, rise 1, and run 3. 1, 2, 3. I could do it again. Rise 1 and run 3. And there's that line. Now in red, I'm going to work on the second line. 2x minus 6y equals -12. The problem with that is it's also not in slope-intercept form. So what I want to do is I want to move this 2x to the other side. That's going to make it negative over there on the right. So I'm going to say -2x minus 12. Now I have to divide each one of these fractions by -6, or each one of these terms by -6, which makes them fractions. The -6 cancels. So I have y equals -2 divided by -6 is a positive 1/3. When I reduce that fraction to the lowest terms, and -12 divided by -6 gives me +2. Okay, so in this case, my b is 2, and my slope is 1/3. Okay, so really close. Here's 2, and then I rise 1 and run 3. Now I rise 1 and I run 3. I connect those dots. And there we go. Now a lot of you already have an idea or concept of what this is, but these lines are parallel. Two lines that are in the same axis that never intersect each other give you parallel lines. Now here's what I want you to notice about the significance of this. When I have these in y equals mx plus b form, the slope of the first one, notice, was 1/3. The slope of the second one was 1/3. So important stuff here is parallel lines have the same slope. Okay. All right, so I have another graphing problem here for you to practice. 2x minus y equals -5. I'm going to write it here. Now again, this is not in slope-intercept form. Graphing a straight line is so much easier when it is. So I'm going to solve for y by moving the 2x over. So I have negative y equals negative 2x minus 5. Now I'm not finished because I have to isolate the y by dividing by negative 1. So it gives me y is equal to positive 2x plus 5. So my b value is 5. That'll be the first point I plot. And my slope is 2. If you like that in terms of rise over run, that's 2 over 1. Okay, so let's graph. My b is 5. So here we go. And I rise up 2 and run 1. 2 and run 1. I can even go down 2 and left 1. And this is the line that I have. Now my second line, x plus 2y equals negative 4. Again, I'm trying to solve for y because it's easiest to graph in y equals mx plus b format. So I'm going to move that x over. Say 2y equals negative x minus 4. And now I'm going to divide each one of these terms by 2 to isolate the y. So it gives me y is equal to, now this is like a negative 1 over a positive 2x, and negative 4 divided by a positive 2 is a nice whole number, minus 2. So your b value is negative 2, and your m value is negative 1 over 2. Okay, so let's plot that. So b is negative 2, and I'm supposed to go down 1, right 2. We'll do it again. Down 1, right 2. I could do that all day long. Down 1, right 2. Or at least till I run out of space. I could also go up 1 and left 2. Up 1 and left 2. And I connect my dots in red. Okay. Now, these intersect each other, so they're definitely not parallel, right? Turns out these are perpendicular lines. Now, what perpendicular means is that these lines meet at a right or a 90-degree angle. My graph looks a little bit off, and it is on this squirrely screen, but those do meet at a right angle. Okay. Now, here's what I want you to take a look at. How are these slopes related to each other? So I have a slope here of 2 over 1 and a slope here of negative 1/2. So it turns out that perpendicular lines have negative reciprocal slopes. What in the world does that mean? Okay, well, a reciprocal means you flip the fraction upside down. The negative means you change the sign. So that's what I did. You take the 2 over 1, flip it upside down, change the sign, that's going to give you negative 1/2. So if you ever need to create a perpendicular line to a given line, that's what you do. You find the slope, you flip it upside down, you change the sign, and then that will work. All right, so to summarize that idea that we just talked about, parallel lines have the same slope. That's our type line there. So we talked about that when we graphed our two separate lines. Perpendicular lines have slopes that are negative reciprocals of each other. I've got a quick couple of examples for you to take a look at, and then we'll stop this video and pick up a third video for this section where we write the equations of parallel and perpendicular lines. Okay? So I ask you, in function form, what is the slope of the line parallel to negative 5x plus 7? Okay, well, first of all, we have to find the slope of negative 5x plus 7. Well, slope, remember, when it's in that nice standard form, y equals mx plus b, is the value being multiplied by the x. So in this case, our slope is negative 5, and parallel, you keep the same slope. So that answers that question. The slope would be negative 5. On the other hand, what is the slope of the line perpendicular to negative 5x plus 7? Notice the same equation. The perpendicular, remember, you flip it and change the sign. So m, and I use that little symbol for perpendicular occasionally. So if I flip 5 upside down and be 1/5, and I change the sign from negative, it'll be positive. So this would be a perpendicular slope, and you could do this for parallel if you want to. It looks like a little m sub 11, but that's parallel lines, and then the upside down t is perpendicular lines. All right, let's try this question again, just a different problem. So what is the slope of the line parallel to 3x minus 5y equals 7? Now here's a problem. Our blue problem up above was easier because that was in the form of y equals mx plus b. This one is not. So that's the first step. I'm going to go to the bottom of the screen and work on that. So right now we have 3x minus 5y equals 7. I need to move that 3x to the other side of the equation. So negative 5y equals negative 3x. Remember, when you move it to the other side, really you're changing the sign. Plus 7. I divide all three of these by negative 5. So I get a final result of y equals 3/5 x minus 7/5. Now what's important here is the slope is 3/5. Okay, so for parallel lines I use the same slope. So m parallel would be a slope of 3/5, whereas m perpendicular would be a slope of negative 5/3. Alright, so this is the last problem I want to put on this video. I hope you'll join me for part 3 of the video where we continue our conversation about parallel and perpendicular lines.